Well, all right, friends, welcome to Chapter 4, Rational Numbers. So this means we're going to be dealing with fractions and decimals. I know y'all are tired of fractions and decimals, but we're going to try one more time to see if we can solidify this information. Okay, first thing, we have a couple vocabulary words I want to go over. Let's give this one a title. This section is on terminating and repeating decimals. Terminating and repeating decimals. Because that's what rational numbers are. They are terminating and repeating decimals. So let's talk about this word terminating. Have any of you heard of the movie The Terminator? Terminating decimals. End. Terminating just means to end something. So like the Terminator is like he would end people's lives, you know? So a terminating decimal, for example, would be like 3.4. See how it stops? Or negative 3.75. And it stops. That's a terminating decimal. Okay, repeating decimal. A repeating decimal is the same number pattern. Repeated forever. Apparently last year was really excited about this, so I put those in all caps. Forever. Okay? So for example, we could have negative 3.212121221, and it would just keep on going. Now on a calculator, you'd probably be okay here. On a calculator, if it was a 5 or higher, then it would round up because the calculator screen ends. It doesn't go on forever. How we write repeating decimals is by using bar notation. Okay, bar notation means we're going to put a bar over whatever repeats. So this would be negative 3.21, and we'll put a line over that. Okay, or we could have 0.5 with a bar over it, and that means it's 0.5555555 forever. You could even have something like 2.76 and then just put the bar over the 6, which means it's 2.7, and then the 6's are what continue on forever. Okay, so the fancy thing about terminating and repeating decimals is that they can both be written as fractions, and that's the qualifying thing you need to be a rational number, is that you can be written as a fraction. Alrighty, so let's talk about what we need to do. The first thing we need to do is convert fractions to decimals. Okay, fractions to decimals. Now, we talked about what fractions mean, right? Last chapter, fractions mean division. So that means we're going to be doing a lot of division, but guess what? We get to use calculators now, so it's going to make it a lot easier. Okay? We divide the top number, which is your numerator, by the bottom number, which is your denominator. So it's the top divided by the bottom. Okay? So now that we're using a calculator, you put on a calculator, put the top number in first, then the divide button, and then the bottom number. Okay, and that's how you can do it in a calculator. Looks like I did some long division practice, so let's just remind you what long division looks like, even though, like I said, I'm okay if you use a calculator. Actually, I'm going to put the numbers down here. We've got the fraction 3/8. So this means 3 divided by 8. So the top number goes on the inside, and I'm going to add like 3 zeros, and the bottom number goes on the outside. Okay, so let's remember some long division. First of all, can 8 go into 3? No. So we're going to put a 0 there, and we're going to bring our decimal point up. Now we're looking at 30. 8 can go into 30. 32 is 4 times. That's a little bit too big. So we're going to do 8 times 3, which is 24. You put that there. So you put the 3 there. 8 times 3, 24. You put it there. And we're going to subtract it from the 30. And a 6. And that's done. And then we're going to bring down the next 0. So now I've got 8 into 60. And I'm thinking 56 is the closest one, and that's 8 times 7. So I'm going to put it above that 0. 8 times 7 is 56. I'm going to subtract 5 and carry the 1. 10 minus 6 is 4. And I'm going to bring down the last 0. 8 goes into 40 evenly, so that's awfully convenient. 8 goes into 40 5 times, and we are done. So this is a terminating decimal. Ta-da! Let's try that one more time. Number 2, we're going to do -4/9. Okay? So the negative is just going to be negative. It just means the top is whatever our answer is, it comes out negative. Okay? So the 4 is going to go on the inside. The 9 is going to go on the outside. I'm going to add like 3 zeros again. And then just remember our answer is going to be negative, because we just have the one negative, so it needs to be negative. 9 does not go into 4, so I'll put a 0 there, bring up my decimal point. Now 9 into 40, the closest one to that is 36, which is 9 times 4. 9 times 4, 36. Subtract. Oh, I got a 4. I'm going to bring down the next 0. Well, we already decided that that was a 4. So 9 times 4 is 36. Wait a minute. That's the same thing over and over and over again. This is how you end up with a repeated decimal. So this one comes out to be 0.4 repeated forever. Okay? So here's a little clue or hint or trick. Hint. Okay, if you have a single repeated number as a decimal, for instance, we had that -0.4 repeated forever. As a fraction, it's that number over 9. Okay? See how it's 4 over 9, and the repeated decimal is 0.4 repeated? That's just a trick with the 9's fractions. Okay? So for example, -0.6 repeating is the same thing. We're just going to take that 6 and put it over 9. Don't lose your negatives. And this one actually we can reduce down, right? Because we can divide both of those by 3. So -2/3. Okay. Another example would be 0.7 repeating. And so you just take that repeated number, and that's going to be 7/9. Okay. It's kind of a cool little trick. There's also a trick with the 11s and 2 numbers repeating, but I'm not going to worry about that, okay? I have one more hint or trick. We're going to call it a trick instead of a hint. I don't know why I'm calling it different things, but that's fine. All right, another trick to avoid long division, because nobody likes long division. Okay, if the bottom number of your fraction or your denominator, bottom number, is a factor of 10 or 100 or 1,000, then we can actually use multiplication instead of division. And so I'll tell you what I mean. Do you want to make the bottom have a denominator of one of these? So if it's a factor, that's when you're going to use multiplication to get to those. And then the top number is your decimal. Okay, so let's see what this actually looks like. So for example, if we have 74 over 100, okay, we already have a denominator that's in a power of 10. So this part right here is going to be our decimal. So we don't have a whole number, so it's going to be 0.74. Done. Don't actually have to do the long division on that. Okay, does that make sense? Here's another example. We can have 13 over 20. So 20 right now is not a power of 10, but we can multiply it. If you think about it, I don't know if you've ever got to handle this much money, but if you have 5 20s, that makes 100. So if we multiply the top and the bottom, obviously you can still do the division if you want to, but you can multiply the top and the bottom because 5 times 20 is 100. 13 times 5 comes out to be 65. And now we can see that our decimal is going to be, we don't have a whole number, so it's 0.65. Okay, you can also do, well, some of them, hopefully you just kind of know in your head. For example, like 1/2. Hopefully you guys just remember that that's 0.5. Or 1/4. And think about that word quarter, right? 1/4, that would be 0.25, 25 cents in a quarter. Huh? See how that makes sense? Let's see. Oh, I think that's all the patterns I was going to show you now. Okay, so does that make sense? You can make, if you can make the denominator a power of 10, then you can just take the top and that is your decimal. All right, and then kind of along those same lines, we can do from decimals to fractions. Okay, and what that looks like is, say we had the number -3.64. Okay, so the -3 is in our ones place, so that's going to be our whole number. This is actually going to be a mixed number. So we're going to have -3, and then we're going to take our decimal, and remember how if we had a denominator of 100 and that was just our decimal, same idea, we're just going to put that over 100 because it's in the hundreds place. If you think about it, that's the tenths place, that's the hundredths place, so it's going to be 64 over 100. Okay, now the thing about fractions is they always want you to reduce them, and right now I can tell that those are both even, and so they're both at least divisible by 2. So I'm going to reduce this fraction. I'm going to divide by 2 and divide by 2. Keep my whole number, which is -3. 64 divided by 2 is going to be 32. And 100 divided by 2 is 50. Well, those are both even again. So I'm going to divide by 2, or if you wanted to, you could have divided by 4 in the first place and saved us a step, but that's okay. So again, we keep our whole number. 32 divided by 2 is 16, and 50 divided by 2, is 25. Okay, those don't have any common factors, so we're done. All right, let's do one more of those. Number 6, we're going to have 2.001. So we've got a whole number in there, so it's going to be 2 is our whole number. And now let's look, what place is this in decimal places? This is tenths, hundredths, and thousandths. So that means we're going to put 1 over 1,000. And we're done because we have a 1 on top. Okay? So that's the basic idea of changing fractions to decimals. You just do the division, and decimals to fractions, you basically just put the decimal over whatever place number it ends. Okay? Good luck. Let me know if you have any questions.